So before we get started, I thought I would just take a second to introduce myself. My name is Lee Briggs. I work at a company called Pulumi, who you may or may not have heard of. I am available on Twitter after the talk. If you aren't able to join us for the live question and answer. I also have a bunch of code that I'm going to be running through that's on GitHub, and I occasionally write on a blog when I don't want to have a 300 thread Twitter thread going. So I'm going to be talking to you today about what's your type, and the main purpose of this talk is to talk about the journey that Pulumi, my employer, went through when implementing the Python SDK, some of the things we learned, some of the background, and some of the historical context. So we'll be talking a little bit about cloud development today, and a little bit about what we learned as we were implementing a type system for our Pulumi SDK. I really value feedback when I do these talks. I'll also share this link at the end. This is just a Google form that will ask you to, provide me with the information about what you thought of this talk. You can also optionally provide your email address, and if you do so, we will provide you with a Pulumi t-shirt. We will not be using this for marketing purposes at all. This is on my own personal time, and I have the free ability to send out t-shirts when I like. So don't be worried about this being kind of captured in terms of marketing content. It's really just to make sure that the talks that I'm giving are the kind of things that you want to hear. So in the beginning, when you were running Python applications, your infrastructure kind of looked a little bit like this. It was servers and switches and racking and stacking in data centers. But as time has gone on, the way that we provision our Python applications has really changed to look a little bit more like this. As cloud providers have become more ubiquitous, both in small and large companies, the way that we provision Python applications has consistently changed. And we really, as an industry, have started to conform on the idea that we want to have declarative infrastructure when we're provisioning things to actually run our Python applications. In order to make sure that we actually are able to provision those applications, an entire industry has sprung up around using configuration languages in order to actually provision that infrastructure. Configuration languages sort of made sense for a long time in order to actually provision infrastructure in cloud applications because it's declarative in nature. You kind of write out a configuration document on the way you want the actual application and infrastructure to look. And as a result, you would be able to run things over and over and over again and get that cloud application running. However, there's a huge learning curve here for anybody who already knows Python, because you now either have to manually author some YAML, and I have personally written thousands of lines of YAML, maybe hundreds of thousands of lines of YAML in my career, and I've made this particular mistake more than once. And I've also had the ability, or the negative experience of handwriting JSON and not being able to comment things and missing commas at the end of lines and all that kind of stuff. So an entire industry of provisioning infrastructure applications has been sprung up over around configuration languages to actually provision infrastructure. And again, as I already mentioned, this has really been something that, for me and during my career has really been a painful part of the experience, especially already knowing multiple programming languages in order to actually kind of get my work done on a day-to-day basis, having to kind of pivot to a configuration language and having all of the negatives of that has really been something that was a pain point for me for such a long time. A bunch of solutions have sprung up around this. You may be familiar with Terraform and the HCL language. Google created or open sourced something called JSONet, which is based on their internal configuration language. And then they kind of pivoted to a Q language, which is very similar, but kind of builds on some of the learnings from JSONet. A small number of people have used the DAR language to actually generate this configuration. And Azure, the Microsoft Cloud, has kind of created this in this other configuration language to just provision Azure infrastructure. So what does all this mean, and why am I talking about this instead of Python? Well, I really wanted to set the scene and kind of talk a little bit about how we at Pulumi started to think about provisioning infrastructure and where the actual basis of it came, and why we looked at looking at doing things in a slightly different way. So we kind of think of it, instead of infrastructure as code, we kind of think of things as infrastructure as software, which as all Python software developers can really kind of get behind as an idea. You're thinking about things like abstraction, functions, the tests that you can run on your infrastructure, being able to have logical control flow when you're writing your infrastructure applications, the expressibility of Python versus some of these configuration languages. And most importantly for me is IDE support, having a proper language server and IntelliSense. So this is the only kind of time I'm going to talk a little bit about what Pulumi does in the next section, simply just to give you an idea of what we do, and then to provide a little bit of context around why we implemented the Python type system in the way that we did. So Pulumi is an infrastructure as code tool that allows you to use the programming languages that you are generally using in your application lifecycle to also provision your infrastructure. We support 4 language ecosystems: Node.js, Go, Python, of course, and then the .NET ecosystem, including my personal favorite, VB.NET. If you'd have told me 10 years ago I'd be writing Kubernetes applications in VB.NET, I probably wouldn't have believed you, but here we are in 2022, and that's what I spent my day doing yesterday. But in order to actually kind of support all of these different languages, we need to produce SDKs in all of these languages that allows us to interface with those cloud providers in order to provision our infrastructure. And you can see I put a red box here around TypeScript. The reason that I've done that is because JavaScript and Node.js and TypeScript were the first supported languages within Pulumi. And TypeScript is unique in the sense that it allows you to actually type all of the actual parameters in a strong way and in a static way using duck typing. So here's an example of provisioning a service account in a Kubernetes cluster. And you can see here in the actual function, I'm able to specify the types that I'm able to the actual types of the input parameters to that function. And we got a lot of feedback from folks saying that this was a really great way of doing things and that TypeScript feels really natural and expressive in doing that. But of course, there's millions of Python developers out there. So we also added Python support. Python was the second language that we implemented in Pulumi, and it took off massively. We did this implementation in 2017, and you can see here the actual GitHub issue where we talk about adding support for Python to Pulumi, and things have moved massively in the last nearly 5 years from where we were originally with the Python SDK and to where we are now with the Python SDK. So what does a Pulumi program in Python look like? I generally come from an infrastructure background. So this is an example of me provisioning a Pulumi program in Python, which is a set of Kubernetes services. This applies to all of the different clouds that Pulumi supports. But let's look a little bit about what's actually going on in this Pulumi Python program. So you can see here in the untyped NS space here, we're creating what we call a Kubernetes namespace. We're able to create a standard dictionary with a bunch of labels that we're able to pass around in a very Pythonic way, just creating a variable that we can then use. The most important thing to look at here is that each of these Kubernetes objects, in this particular case a service, has a dictionary of properties that you want to pass to it. Kubernetes requires you to specify metadata. It requires you to specify specification things. And you can see here, these are generally just Python dictionaries. And it's really more apparent when you look at the deployment part of things down here. When you're looking at the specification, you can see we're able to pass variables around in a very simple way. But we have to have these kind of like untyped, like free-flowing dictionaries in order to actually propagate all of the different values that a Kubernetes deployment needs. What does that actually mean when you're actually using things? Well, the reality of this, and I wrote this yesterday, and I made a lot of mistakes when writing this code because I didn't know what the actual values were. I didn't know how to actually populate these values off the top of my head. I had to do a lot of looking up. I had to do a lot of context switching. And the main problem came from these kind of like untyped dictionaries. So I'm going to pause there and then pivot into the actual way that Pulumi works with the Python SDK to tell you a little bit about why this was a difficult process and how we went about improving it in a Pythonic way to allow us to make things a little bit easier on you, the developer, and us, the supporters. So how does Pulumi work and how is it actually interfacing with these cloud providers? Well, when you think about how you're actually defining infrastructure with a Pulumi program and with Python, what you're really doing is effectively writing a lot of what we call JSON literals. We already talked a little bit about this when we talked about the actual configuration document and the actual ability to provision infrastructure using configuration. Infrastructure as code is to a large degree about writing a lot of object initializers, effectively just JSON literals as arguments for resource constructors. And if we take a step back here and look at the actual code again, this starts to make sense when you realize that we just essentially have a lot of dictionaries in Python that we then convert into a JSON system that we can then send to the cloud provider API. So it makes total sense that we can kind of craft this infrastructure deployment as a sense of dictionaries, but these values in the nested properties within the actual deployment itself, the fact that they're untyped really just brings us back to where we were when we were writing JSON and kind of making those mistakes. And I already mentioned the main thing that we focused on when we were looking at using Pulumi and these kind of like language SDKs, and in particular Python, is feeling like you're actually able to touch the infrastructure in a way that allows you to feel like you are essentially just writing pure Python code, and the feedback loop should be just as quick as it would be if you were writing your application. So we already talked about what the infrastructure model looks like and how it's just a series of JSON literals. So how did we go about making this a little bit easier for you in terms of using Python? Now, let's remember, as an industry, we have all settled around the idea that we want to declare infrastructure, and Python is imperative in nature. You're obviously, as Python developers, probably pretty used to the idea that you need to catch exceptions and make sure things exist and do if statements if something has already been provisioned. When we are actually when we're actually writing infrastructure code, we don't necessarily want to go through that same pattern. And as a result, we still need to be able to write our Python code using an imperative language, but get a declarative end state when we're actually provisioning our infrastructure. So we still need to be able to say, run this code 1,000 times and get the same result. And if something already exists, we don't want to actually have to recreate it each time. We just want to return to the program that these things are already existing. But if we use a configuration language like JSON, we don't get any of the benefits of Python when we're actually authoring our infrastructure program. We don't get any of the language auto-completion. We don't get any of the ability to comment our code. We don't get any of the abstractions. You don't get to use object orientation and create reusable abstractions for your friends and colleagues when you already know how to create that infrastructure. And then finally, there is a communication model that is very different to the way you would normally operate within Python. And what we're talking about here is the asynchronous nature of the cloud providers that we're kind of talking to and that we're interacting with. Here is a diagram of what this looks like when we're actually provisioning a Pulumi program with Python. And we have this model within Pulumi of what we call inputs and outputs. And these are uniquely typed objects and values in a Pulumi program. If you look here, when we create a virtual machine, we have a result of creating that virtual machine, an IP address. That is usually sent to us by the cloud provider. You can optionally specify it, but it comes back from the cloud provider in an asynchronous fashion. And we have to wait for that result to come back from the cloud provider before we can do anything with it. We also have what we call inputs, which are often values that come from other resources that we've created in the cloud provider. So let's say we provision a virtual machine and we have an IP address that then is propagated from that virtual machine. And we want to pass that IP address to the load balancer as a target. And then we also want to specify our own port and specify that. You can see here this input and output flow is very asynchronous in nature. And just to take a little bit of a pivot here, what was really unique about the Pulumi implementation is supporting so many languages when provisioning your infrastructure meant that we had to come up with a brand new type that was supported across all of the languages that we wanted to support. So we needed to come up with a type keyword that was not used in .NET, in Go, in Python, and in the Node.js ecosystem. And let me tell you, coming up with a mechanism there with a set of reserved types and a set of keywords that was not used across all languages was a really, really fun exercise. And we've got lots and lots of bug reports to show how we made mistakes along the way. But this is really where the type system starts to take real effect, because when we're returning these values, when we're kind of pushing and returning these values, we often need to wrap these return properties in this special type, which we call inputs and outputs, in order to actually make things usable when we're passing things between different properties. So what does this look like when you kind of bring it all together? So we talked about kind of building JSON literals, but in a way that is easier for the developer, but also being able to actually kind of deal with these asynchronous values that we're kind of passing and getting from cloud providers, so that we can deal with them in a way that understands the asynchronous nature. As another side note as well, we also have to build a dependency graph with these values as well. So it wasn't a case where we could just do async IO type things that are already available in Python and Node.js, because we had to have those reserved properties, those reserved words across languages, but we also had to deal with the eventual consistency of cloud providers. If you've ever used something like AWS, I always like to make the joke that it doesn't value your time, because things will often take anywhere between 30 seconds and 10 minutes in order to actually complete properly. And Pulumi will consistently poll those cloud provider APIs in order to make sure that that value has kind of returned and come back. Now, of course, we may have been able to use the async IO nature directly in Python, but it would have made that extremely difficult to port to other languages that we plan to support. So we had lots and lots of different problems that we wanted to solve when we were kind of doing this implementation. So what does a Pulumi program look like with solving all of these problems in one go? Well, this is the exact same piece of code from earlier, using the actual Python type system, using MyPy, and using all of the type capabilities at our disposal within the Python ecosystem. And you can notice the first thing you'll probably recognize here is that the untyped dictionaries have essentially disappeared. We no longer allow them to be untyped. We do allow them to be untyped, but we also allow you to be able to type them in a strong way and actually provide the actual input types to each of these input properties. So let's take a look at the metadata here. Kubernetes already has some kind of like great typing systems when it comes to input properties. So we just push these down into a Python type system that allows us to actually kind of build the actual property values in a way where we know that the values are acceptable. What's super unique here is that when we're actually passing values from one place to another, for example, when we create this namespace here, we can also pass the value of the name of that namespace to another resource. And this is what we in Python call, in Pulumi call an input. So we're passing an output from the namespace, which is the result of the created namespace, as an input to the actual service itself. And this typing ability really increases and massively makes the feedback loop much more desirable for you as an infrastructure engineer or a Python developer when you're provisioning your actual code. And again, a lot of the reason for this is because these are just configuration documents that we're having to send to a cloud provider API. And that cloud provider API has very specific values that you need in order to actually create a piece of infrastructure. We as developers don't get to define the API. We're not kind of creating the API ourselves. We're relying on an upstream API that has been defined for us by the cloud provider or by the Kubernetes cluster or by Azure or AWS. And so by using this type system, by using these input properties and creating this mechanism in which we are knowing the input values, it really improves the feedback loop. So what does that look like in practice? Well, let's do a quick demo. Please bear with me. I am live coding here. I may make a mistake. And this is as live as you're going to get when it comes to actually live coding. I'm actually going to go through this process in real time of actually creating some infrastructure using our Python SDK and showing you the difference between using an untyped mechanism and a typed mechanism. So here's my IDE, and in this particular example, I'm going to create an AWS S3 bucket, and then I'm going to upload some files from that AWS S3 bucket into that actual bucket as a bucket object, which you can see here. And then I'm also going to create a bunch of dependent resources here. And you can already see if we were using JSON as a configuration language here, or YAML as a configuration language, we would not be getting this kind of feedback, right? We would not be getting any information from the actual Pylance or the Python interpreter that we'd made any mistakes. So this is a really kind of like natural, traditional Pythonic way of being able to kind of define infrastructure. And you can see here what I've done is I've commented out this example here just as a reference for myself of being able to create the S3 bucket. So what does that look like in practice? Well, let's define our web bucket equals aws.s3.bucket. And you can see, of course, that I get all of the same IntelliSense capabilities that I would get if I was writing a Python application, but now I'm getting it in my actual infrastructure code as well. So this type system is already coming to use for us because we're actually getting the actual different types that are available in the actual SDK. If you're using YAML or something else or another kind of like configuration language, the actual expressibility you would get would be much lower. But the type system is also really helping us understand the things that we need to be able to do in order to make this infrastructure program work. So then I'm going to populate my bucket, and I'm going to call it just bucket, like so. And you can see here, like straight away, my IDE is giving me great feedback about what I need to actually do in order to make this successful. So I can go in here and I can look at the definition of the S3 bucket, and I can see all of the different input properties that I need for an S3 bucket. And you can see I can see all the different properties for creating an S3 bucket here. But notice, look, we're creating these properties with type requirements on them. So for example, force destroy obviously needs to have a Boolean input, whereas a policy needs to have a string input. These are the kind of like pieces of information that we wanted to pass down to you when you're actually using our Python SDK. Now, of course, I can specify these values in a completely untyped way. So I can do website, index, document, index.html, like so. And of course, this would still work, except this would still work, except I would have no idea if this was a successful, like this was a successfully created, successfully fulfilling the contract of the cloud provider's API. I would have no idea if this dictionary was valid or not. So I want to make sure that those values are correct and that they're propagated correctly. So what does that look like when I'm strongly typing it? So if I do website, you can see here that I'm already getting information back from my IDE about what is required when I create an S3 bucket. So I can do website equals, and then I can pacify arguments to this particular property, bucket website args, and still get information about what is needed on my bucket website argument. So I know that there's an error document, an index document, and redirect rules. Now, again, as I already mentioned, if I wanted to make this untyped dictionaries, I totally can. But when I go to run my Pulumi program, I want to make sure and be happy with the idea that the information that I'm providing is going to be valid for the cloud provider's API. And by using this strong typing, it is more verbose, sure, unless you wanted to use the from style imports. AWS import S3. So of course I could do this and then just do bucket website args like so, to make it a little bit more palatable. But I personally like to be very explicit with my Pulumi programs and my Python code. I don't personally mind kind of writing a little bit more to make it a little bit easier for somebody else to come along and actually understand what's happening. So let's finish this up, and we'll populate our index document here like so. And you can see my IDE is now happy with me being able to actually populate this particular AWS S3 bucket. And there's a bunch of other stuff inside this Pulumi program that takes advantage of this particular ability to define infrastructure with correct typing. Now, what is interesting here is that if I provided the wrong value here, or something that was not a valid value, for example, if I did, and I need to think about what I would do here, true, it looks like my IDE autocompletion isn't working right now, but generally what happens if I had spun up my IDE autocompletion correctly is that this would actually tell me that the input document, the index document, has to be a string. And so I would get great feedback from the actual IDE that's telling me that the properties that I'm providing to these particular input properties is not valid. So what does this look like in reality when we're actually provisioning a Pulumi program? I'm just going to quickly finish off this example that I sort of had half finished earlier. Touch index.html. And you can see here, because I've used the type system to actually provision this AWS bucket, I'm able to actually get a successful Pulumi program directly from this particular piece of code without actually having to kind of go through the feedback loop and make a bunch of mistakes and kind of have problems. If you think about how you would do this in a configuration language mechanism, the ability to be able to do this would be much more difficult. So we're talking about the inputs and outputs that we get as well when it comes to the type system. You can see here, if I take a look and hover over what the actual property value that I get when I look at the outputs from the web bucket, you can see here there is an actual type value of something called an output string. So this is not a standard string. This is not like a Python string that you can pass to any other value. You have to wait until the actual value has resolved and come back from the cloud provider in order to make sure you can use it. And Pulumi has a very specific mechanism in order to be able to do this. We have something which we call an apply. An apply is basically telling the Pulumi program to wait for the actual property to resolve, and you can see it used here. We need to wait for this bucket name to resolve before we're allowed to actually use that value. This is a fairly traditional mechanism in generics, and so we are just using the property output T or output string in order to actually get this value. But it's really important to understand that from a Pulumi perspective, kind of being able to type these values but still make them asynchronous was one of the great things that we were able to use within Pulumi. So what did we learn from this? And I can't believe I've spelled lessons wrong. That's really entertaining to me. What did we learn from this particular process while we were kind of going through the actual process of kind of building out this Python SDK and using these type systems? Well, the first one is that I mentioned that the feedback loops were super important. We had hundreds and hundreds of issues open from Python developers just like yourselves, which told us the Pythonic way of being able to actually do things and the feedback loop importance. Some of the things that we really got from a feedback loop perspective were that, like, in our original SDK, our actual code used, instead of using Python snake casing and the Pythonistic kind of like mechanism for declaring variables, we actually generally tended towards the Node.js side of things because that was the first language that we introduced. So a lot of our examples ended up looking like this, which of course is not a particularly Pythonic thing. And the feedback loop was really great in terms of like both from a developer's perspective, but also from us. Python developers, we have learned, are just really great at kind of providing information about the Pythonic way of doing things. And I personally, as a solutions engineer and developer, developer advocate, have learned a whole bunch about the Python ecosystem just from friendly Python developers like you folks. We also learn from a feedback loop when dealing with remote APIs, having that information at the touch of your fingertips in the actual API, in the actual IDE, in the actual SDK itself is super invaluable when it comes to defining infrastructure. We've been down this road now for 5 years. As you already recall, we implemented Python support in 2017. And we've made some great strides in the Python SDK and the way that it actually works. But it's not all been great, unfortunately. There have been problems when we've been kind of developing this type system. We use MyPy for a static typing mechanism, and we generate really, really large SDKs for cloud providers. The Azure native provider within Pulumi is incredibly large. It covers the entire surface of the Azure SDK. And that SDK is now getting so large, it's starting to create problems for MyPy and actual local development. Obviously, I have a super beefy MacBook Pro with a bunch of memory, but not everybody has that at their capability. And so we're now working really heavily on reducing the time it takes to actually use MyPy when you're using static typing, when you're developing Pulumi programs. And we're also looking at using lazy loading of sub-packages in order to make this a little bit easier. One thing that I personally have seen or have started to believe in the Python ecosystem is that the type system is really added on as an afterthought. You folks are all so used to kind of dynamic typing in the day-to-day usage of the language, but static typing is so useful when it comes to creating infrastructure code because that remote API is defined by somebody else. And so we're having to kind of implement new things and new mechanisms in order to make things much better for us. And you can see both of these issues have been open for a little while. I've kind of included them here because they are continuously a work in progress. We continue to make things better here. We have made really large strides in the way that the Python SDKs are actually managed and the actual way that the types are generated. And this is a continuous thing today in order to make the Python SDK a first class and best class citizen when it comes to the Pulumi ecosystem. And I've pressed the wrong button there. So one of the other things that we started to kind of notice is that when we're kind of validating a bunch of types, when we come to actually defining SDK and defining the SDK, when actually authoring Pulumi programs, any properties, and you just saw this in action here, that the type check-in is disabled for properties, that sometimes you can get runtime issues and panics when you're actually defining Pulumi programs using our output model. And you can see here, this is another example of an issue that one of our developers has opened. And again, we're continuously working on kind of creating new mechanisms to make this easier and easier. Sometimes we feel like a little bit like we're fighting against the Python type system and against MyPy being an added an added feature that is not natively involved in the language. But we do believe that this is still a first class and the best way to actually define infrastructure, especially so that you don't have to kind of go through a learning curve of learning like a secondary DSL in order to actually define infrastructure itself. So how can you, as Python developers, help? We desperately need feedback from you as Python developers on a day-to-day basis about how this feels to you when you're defining infrastructure. We have lots and lots of awesome customers that are using our Python SDKs, and we get continuous feedback. But the more feedback we get, the better the Python SDK becomes. Pulumi has a free and an open source tier. I'm not here to sell you the product, but it would be really helpful for us to kind of get in front of all of you amazing Python developers that are writing amazing applications and writing great Python code on a day-to-day basis. What is the correct and Pythonic way to be able to define our SDKs? Pulumi uses code generation to generate those SDKs in order to make sure that we can add more languages down the line. And sometimes that code generation does not generate Pythonic SDKs. Sometimes it doesn't feel particularly Pythonic. So if you use Pulumi, even in just to play around with it, it will really help us be able to define a much better Python ecosystem for other Python developers. We've seen Python developers from startups to large enterprises, from data scientists, all across the spectrum are using Pulumi in order to define their infrastructure code. But the more information that we get about the Pythonic way of doing things, the better the Python SDK becomes. And then the final thing that I'd like to ask in terms of how to help is, I know that on a day-to-day basis, the ability to have dynamic typing in your applications is super, super useful because it means it's flexible. It means you don't have to worry about all the things about like declaring the types when you're declaring variables, and like worrying about reflection between different variable types, like something like C++ or Rust or Go. Python is obviously really, really great in allowing you to be expressive and flexible and really get things done in a quick way. But if you aren't considering using MyPy and static typing in your day-to-day workflow, maybe consider it, even if you're not authoring infrastructure definitions, because it improves the ecosystem. One of the things that we see on a regular basis when people are comparing our different SDKs is the type system that's kind of bolted on around Python. I personally believe there can be improvements here, and we have sent several improvements up to the MyPy ecosystem. But we would love to hear a little bit more from you folks as people who are used to dynamic and duck typing mechanisms, what that might look like when we're actually kind of using this in the Pulumi SDKs. I keep pressing the wrong button. Sorry about that. So I have actually finished early. I thought this would go a little bit longer. I thought we would go for the full hour, but I managed to talk pretty quickly and get through this a little bit quickly. Like I said, feedback is super, super important to me as an individual. I'd love to hear what you thought of this talk, and I'd love to hear anything that I can do to make these kind of talks better. Please feel free to leave me feedback. If not, I look forward to kind of like seeing you in another one of my talks in the future. But with that said, thank you so much for listening. If you would like to kind of ask me more questions, I am available on Twitter at BriggsL. And I also have a website where I write about all different kinds of infrastructure engineering, software development, and other things on a regular basis. But with that said, thank you very much. And I appreciate everybody's time today.